So I'm Evan Dorn. I run Logical Reality Design, which is a web technology consultancy firm here in Pasadena. We do a lot of work for an assortment of startups. I'm here to talk about technical debt today, which I don't know how many of you know that term. But I want to start by telling a story. And maybe this is a story that you have heard, maybe it's a story you've lived, maybe it's a story that you might live and might want to avoid. So you've got a new web startup idea. Somebody's got a good idea. You've got a founder, you've got a little seed capital, you put together a technology team. It can be anywhere from one freelancer to 3 or 4, hired developers. So you dive in, and in the first 6 months, you get a lot done. A whole bunch of features built. Maybe you get to your MVP in 6 months, you get launched, you start getting customers coming in. Then things slow down a bit in the second month. Now you've got customers, and they're reporting bugs, and you've got to get those bugs fixed, and you've got to triage and decide between different features. So the development of new features slows down a little bit, but of course, that seems pretty normal. But then another year goes by, and now things really are slowing down, right? Your product people are asking for new features from your development team, and it's just taking a really long time to come out. You're spending a lot of money, you're not beating your competitors to market with new features. People are getting frustrated, you start to lose developers, somebody leaves for another company, and things are just kind of grinding to a halt. I don't know if any of you have seen this process before. Our company has made about half of our business in the last 4 years out of being the people you call at 2 years when this process is happening and your development is going really slow and you don't know why. So we've seen it a lot over a lot of different startups, and I've become passionate about managing so-called technical debt, which is what's going on when you see this happen in a company. So I want to do a quick show of hands. How many of you people work with a startup or would work with a startup soon that involves computer software? Okay, so that's just about everybody in the room. Raise your hand if you yourself are a programmer or a developer. About half of the people. And whether you're a programmer yourself or not, raise your hand if you... Raise your hand. Is everything all right? Raise your hand if you manage developers or programmers. And about a third of the people in the room. Okay, so of the people who just raised your hands, the managers, put your hand back up if you think you can give a clear definition of technical debt. And I see 3 hands, 4, maybe 5. Okay, so particularly for the people who didn't raise their hands in that last call, you are the most important audience for this presentation. So what is technical debt? Put simply, technical debt is poor quality software. There's a challenge with software and computer code, which is that it's largely magical to the people who aren't writing it. This is the same as any technology, right? I mean, if you didn't design a car, you're not a car mechanic, you don't really understand that well how it goes under the hood. And software can be more this way. So it's a normal human behavior to evaluate software based on whether or not it does its job, right? Does the website run? Can people sign up? Can they do whatever it is our website does? And really think that that's all there is. It either works or it doesn't. But the truth is, like any other product, software has quality under the hood. You buy 2 cars, and at purchase time, either one will get you from point A to point B. But one might be from a company with a very high reliability record, and the other one over the next 5 years is going to cost you a ton in maintenance costs. So there's a quality difference, even though the 2 things will ostensibly get the job done. The same is true of software. I'm sure you've heard terms like spaghetti code, loose coupling, clean modularization. These are real phenomena, but often they're not understood well by people who are not doing the programming themselves. And this can cause a lack of communication over code quality between management and engineering, and this can be a real problem in startups. So we use the term technical debt because debt, just like financial debt, is actually a really excellent metaphor for most of the processes that happen in code quality. When we choose to take out a loan, we do it because there's a short-term advantage, right? We get a bucket of money in our hands right now, which may help us get to market sooner. But when we do that, there's an awareness that that is going to have costs down the line. We're going to have to pay interest on that debt. We have to do debt service. The same thing happens when we make short-term decisions when we're writing computer software. There's do it right, and there's do it fast, and they are different when you're writing code. The problem is, well, and the debt metaphor is great, because the short-term decisions will accrue costs down the line. You're going to write more complicated code, it's going to be spaghettified, and now your future features and your future bug fixes that you try to write are going to take longer because your developers are working with a lower quality code base. So it really is very similar to financial debt in that sense. But there's one key difference. There's no balance sheet, right? When you use a credit card or take out a loan, your CTO, or excuse me, your CFO can show you the bottom line of exactly what that's costing you. Nobody has that number for technical debt, and the result is that it tends to get ignored, and we tend to let these short-term decisions accumulate in our software. They have ongoing costs, development slows down, and nobody's really aware of why because there's no number that anybody can show for it. So one of the main things I want to talk about is how to mitigate this process. But I want to toss in one more metaphor next, which is I've found very useful the metaphor of the foundation of a home. When you build a home, you design it, you pour a foundation, and it's going to hold the home up. But 50 years down the line, there may be a significant quality difference between a foundation that was well poured with high quality concrete and a foundation that's kind of crumbling or turning to sand, particularly when you go to add that second story addition to your home. You may have your contractors come out and say, you know what, this foundation's just not strong enough. We need to tear out the whole foundation before you can add the second story. And now what you thought was going to be a $70,000 addition to your home becomes a $250,000 addition to the home because you have to lift the whole home up, tear out the foundation, pour a new one, etc. Software is a little like home building in this sense because additions are what we are doing every day. If we're running a web startup, we're doing new features week by week. As we do iteration, we're trying to satisfy our clients. So keeping the code clean and agile so that we can move forward is really important, and that requires a good foundation. All right, so there are 3 ways that technical debt happens. I'm going to talk about each independently. The first one is inexperienced developers who don't know how to avoid it. And this does not necessarily mean unintelligent developers. One of the most important situations is that a lot of people, really smart people, come out of school with a computer science degree, which can teach you a lot about the science of making computer software. Algorithms, the mathematics of language design, and that sort of thing. What they can't teach you in a CS program is how to manage a 4-year-old project that has 10,000 files in it, right? Because you just don't have time in a CS program. You're limited to what you can do in 1 semester or maybe 2. So there's kind of a second discipline, to my mind, of software engineering, which is managing the design and architecture of large projects. And that isn't as easily taught in an academic setting. It's really something that people learn on the job. So we get a large influx of new developers every year, and it takes them a while to get up to speed on this process, especially if they're not working in a startup or a company that has a culture that pays attention to technical debt. But the second and more important way that I think technical debt builds up is social pressure. We are building startups, most of us, right? So we're trying to go fast. So there's constant time pressure. Your developers want to make you happy, right? You're going to ask them for these features, you want it soon because you've got to get it to market. So that is an implicit pressure to always pick the fast solution rather than the better or cleaner solution if the cleaner solution will take more time, which it usually does. So there's that constant pressure. And you know, your developers, as I said, they want to make you happy. They don't want to say no when you say, can we get this done on time? Because they want to feel good about their work, and they want you to feel good about their work. Unfortunately, this leads to a communication breakdown where the engineering team never says, you know, it's going to cost us if we try and do it that fast. We'd really like a little more time to do it right. But keep in mind that your engineers would like to be able to say that to you. So if you as a manager can make room for that to be an acceptable conversation, if you can listen when they're telling you, you know, we're accruing some bad code, we really need to spend some time and fix this, that awareness will help the smoothness of your web startup down the line. Likewise, engineers don't want to push back and say no. They don't want to say, no, we can't get this feature done. And then the final social pressure is that it's well known and well established that estimation is always wrong, and estimations are always optimistic, right? And frustratingly, like, I mean, psychologists have spent years researching this. They found that you will always underestimate the time it takes to complete a task, even if you know that that's true and try to take it into account. It's been demonstrated over and over. So even if you ask the engineers how long it will take, you're not asking, can you get this done in 2 weeks? You're asking, how long will it take? They'll say 3. And then At 3 weeks, they're putting pressure on themselves to make that true, even though in reality they probably should have said 5, but nobody can. It's well known psychologically that nobody can make that determination up front. So, then there's a third way that technical debt happens, which is just when software projects last for a long time. And this goes back to our foundation metaphor a little bit. So when we're building one home, we design a foundation for it. Likewise, when we're building a piece of software up front, we may lay out all the features we expect to build over the next 4 months, and we'll design an architecture that's suitable for that set of features. But of course, software is something we add to all the time. So a year goes by, 2 years goes by, we now have a much bigger project that's trying to do a lot more things. And the decisions we made 2 years ago that were the right, clean decisions at the time are no longer the right decisions. And so that is an accumulation of technical debt, even though we did everything right. We need to go back and redesign parts of the site that are already working in order to keep moving forward. So, what's the effect of technical debt? Well, the primary one is cost. We're all business people. We're all trying to get something to market. We're all trying to make money. But labor is one of your main costs, and the primary function of technical debt is to make future software development slower. So if you're paying your engineers several $1,000s a month and something takes them 3 days when it should take 2, that is money straight off of your bottom line. And when I use a debt metaphor, people will often think, oh, well, so that's adding 15 or 20% or that sort of thing. But when you look at a project where nobody has paid attention to technical debt for 3 years, try to imagine what would happen if you made every purchase on a credit card for 3 years without thinking about it, never making a payment, and never looking at your bills, right? The debt load that you can be carrying is enormous. And we're right now working for 2 projects where my experience is that the amount of time features take is a 3 to 5x multiplier over what it should take. That's really not something that any business can afford. The second cost, of course, is calendar delay. If it takes your developers more time to get something done, then that's a couple of extra weeks in getting that new feature to market. That's users that don't see it, that's more time for your competitors to get ahead of you, etc. These are also things you don't want in your business. The third major effect is frustration. Everybody on your team is going to start hating it when they come to work. Your product people are going to be frustrated that they're asking for features and it's not getting done. Your CTO is going to be, or your CFO, excuse me, is going to be getting frustrated at how much money is being spent. Your developers are not going to be liking opening up ugly code day after day and having to slog through it. One of the main costs of this can be HR problems, right? You can start losing people if they get too frustrated over the situation with the software. And one of the
word is will. You will lose people.
You will lose people. And importantly, you'll lose the people you most don't want to lose. Because the people who are going to be most frustrated are the people who actually know how software should be written well. They're going to be the most frustrated over looking at bad code every day if they haven't been given the time to clean it up. And the people who are most likely to leave are the people with the highest level of skills who are most confident they can get a job elsewhere. So you're going to lose your best talent soonest if you allow this to accrue in your project. That obviously is something that can be really toxic to a startup when you're short on time. And of course, ultimately, when these things add up, it can lead to failure of a startup. And I've seen this, unfortunately, far too many times over the last few years. Occasionally, people come to us asking us for help with cleaning up their software, and I have to tell them, it's probably too late. If you have the budget, you're going to be better off starting over. If you don't, it's time to throw in the towel. And that's not news that anybody wants to hear, but it does happen when you let technical debt get too out of control. So, what do we do about it? Well, the first thing we need to do is be aware of it and treat technical debt like any other debt. That doesn't mean it's always a crisis. That doesn't mean it's always bad to make a short-term decision, right? I mean, we're all in the startup world. We get investment, we take out loans because we need them, right? There is an advantage to getting money earlier. There is likewise often an advantage to getting features done sooner. The difference is you need to be aware that you're taking out that debt and treat it accordingly. If you put something on a credit card, you need to make plans to make monthly payments to keep the principal under control. If you push your developers to produce code quickly for a while, you need to make plans after that to make payments against that debt, which is called a refactoring. So refactoring is the software industry's term for taking software that works, and rewriting it so that it still works, but it's cleaner under the hood. And that sounds bad, right? I mean, you chuckle, right? Because it's really hard sell often if the managers don't understand this process. Like, I bought the software, it works. Why should I let you guys spend 2 weeks of my money rewriting it? And the answer is because that's a down payment against your debt. And that will reduce your interest, and it can be a long-term savings for your company. So the next big thing I want to say is use measurement tools. Obviously, no piece of automated computer software can perfectly tell you whether your software code is great or not. Really, only a good programmer can tell you that. But there are automated tools out there developed over the last few years that can take a look at your code and they can do a remarkably good job of telling you if it's good or not. Because they can look for obvious things. You know, this file has grown to 7,000 lines of code all in one file. Or this function has 26 if statements in it. Maybe we should break it apart into smaller pieces. We can look for these things in an automated way. And there are a lot of these tools that give us a nice visual look at the quality of our software code. That gives us the closest thing we have to a company-wide balance sheet. In every weekly review of your product, you can plug it into the software and show management and show your engineering team lead, this tool scores our code at a B- right now, and these are the files that it thinks got a lot worse this week. Maybe we should stop and clean them up. So some specific guidelines. I want to give some specific guidelines both to managers and to the developers. So managers, be aware that when you push for short-term deadlines, you are asking your developers to take out a loan. Not necessarily a bad thing, but just think about it that way and make sure you have plans to service that loan. Try to make an environment that is amenable to your software developers communicating their thoughts about the quality of the code. Remember that a developer has pride in his or her work. She doesn't want to come to you and say, you know what, my code stinks and I need to fix it, right? That's a really hard thing to say, but it's an important thing for you to be able to hear. So you need to create an environment where it is okay for your developers to talk about the quality of their code. Maybe you need to go ahead and ask for that up front. And finally, make sure that your plans for software development include time periods for regular refactoring. 1 day a week, 2 days a month, something. Your developer's job is nothing but cleaning up the existing code so that things stay smooth going forward. All right, so that's my guidelines for the managers. For the developers, remember that when you make the decision to do something the fast way as opposed to the good way, you are taking out a loan on the company's behalf that the company is going to have to pay for. And as the developer, that's probably not a decision you should be making by yourself. The CFO should be making decisions about loans. So think of it as your job to always write clean code and always refactor existing problems unless told otherwise. So when you're budgeting in time for a feature, budget in the time to do that feature and clean it. How many developers, raise your hand, heard the phrase red-green refactor? Anybody heard that? Okay, so for all software developers, look up the term red-green refactor as a phrase. Look it up, learn it, use it. That's a process that will help keep your code clean on a continuous fashion. So then when you have a deadline, that's the specific ask from product to go ahead and take out a loan this time because we need something done sooner. Okay, then as I said, as a company, communicate about your code quality, make plans to service your debt, regular refactoring. And finally, use the best practices that have been developed in the software industry over the last couple of decades. This isn't rocket science anymore. People have been working on the software management process for a long time. You've probably heard terms like test-driven development or behavior-driven development. You've heard agile. You've heard code review. You've heard pair programming. So we have a whole bunch of them written down here. You've got Scrum, Kanban, stand-ups, retrospectives. All of these are tools that are designed to help you manage the quality of a piece of software as it moves forward. Learn about them, figure out which subset of them work for your team, and use them. Try not to just get in the habit of just hacking away at the feature this day. Think about how you're doing it. If you use any good subset of these processes and if you have better communication and awareness about technical debt between management and the developers, then I guarantee you're going to have a smoother and more successful experience with your web startup. I'll open the floor to questions. Yeah.
Yeah, when you're working with the future and you're working with, you know, whether it's HTML2 client, yada, 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 and you're looking at frameworks and, in a sense, the ways of Ruby on Rails, or PHP, ASP, things of that nature. How do you? Yeah, then you talk about all of the what you think the problem is, and for customers you solve the problem, but yet as you go along, you realize that there's a bigger market, and so you start to migrate in that direction with your code. So do you suggest that startup companies start with a particular type of a code for the future?
Can you rephrase that question real fast?
Yeah, he's asking about, I'm sorry, what was your name?
Mike.
Mike. So Mike is asking about a number of different unanticipated changes for the future. There could be new versions of software that you need to deal with. There could be pivots in the direction of your company. There could be new features you didn't need, new features you didn't know you needed when you started the software. The answer to all of these is pretty much the same because they're all unanticipated changes. They come from different sources, but this is what the term agile was invented for, is how do we plan for the future? And the answer is keep your management process and the quality of your software in a place that you can make any change easier than you could if you were really locked into big things. So when a new change comes along, whether it's I need to upgrade Ruby on Rails from 3.0 to 4.0, or we're going to pivot the company in this direction entirely and I need to reuse code, either of those things is going to be easier to do if I've got 20 small, cleanly tested, well-modularized files versus one 6,000 line file that is going to break every time I touch it. So there are a whole bunch of different sources for changes, but the answer is usually the same, and that's keep things clean.
Okay, so we're going to hand the microphone to John. If you got a question, raise your hand. John's going to hand you the microphone. Stand up so everybody can see you, and say your name and your question.
Hi, my name is David. There's an additional kind of debt that is also happens. Most of the time about developing code and software, but there's the support side. If it's poorly designed, you're going to have a lot of issues trying to patch it and answer people's questions when it doesn't work. And then the other side is like the interface and the user, your customer. If they don't find it easy to use, then they're going to not buy it, or they'll buy somebody else's too. So I think there's a big impact if you do what you're saying to make it better for a lot of different people.
Right. That's an excellent point. There are other costs to your software and your product if it's hard to support because it's buggy, or it's hard to support because its interface design is poor. And there's, that's a different concern than the quality of the code, but there's an overlap there. Because if the code is of high quality and easier to modify, then when those problems arise, you're going to have an easier time fixing them quickly. But I agree, that's an excellent point. Yeah, Eric.
My name is Eric. I'm a mobile app developer. As a developer, the biggest issue is when clients come to you, when you tell them it takes longer to do our code clean. Oh, sorry. The problem is when clients come to us for a proposal, and then when you tell them we do clean code, it's going to take longer and more expensive. They tend to just compare another company. Say, oh, that company charged me less, develop faster. They don't know if they couldn't tell, if your code is clean or not. That's the problem. So they always go with the cheaper solution, faster solution, even though we tell them we have cleaner code, but they can't compare, they can tell. So how do we convince them that we are cleaner in a way, right?
Well, start by showing them the recording of this presentation.
Oh.
And similar ones on. But no, use code analysis tools is the thing that I have best found helps, because a lot of people come to us with existing software. They're like, things aren't getting done and we don't know why. And I look at the code, I'm like, okay, I can tell why you're not getting things done. And it has nothing to do with your developers not being smart enough, right? There's nobody in the world who can modify that code quickly, right? It just can't be done. So you drop in a code analysis tool, right? If you are using Ruby, which is the language that I do a lot of my work in, we use Code Climate. But there's tools like this for lots of other software, and these will give you a report card. They will say, here's the quality of your code. You've got 80 classes that scored an F because they've got duplicated code and massively complicated methods and that sort of thing. And that gives you something you can show them. Now, they may or may not believe that. And they may think it's not real and that they should just go for the cheapest, fastest solution. And at the end of the day, frankly, if they are that resistant to it, I would say that's probably not a client you want to work for anyway. I mean, I know that's a hard decision to make when you need to pay the bills. But someone who is that focused on one aspect of the business and is unwilling to consider things that will have long-term costs for them, because remember, that's the point here. I'm not saying this just out of a matter of pride to have clean code. I'm delivering this message because I've seen companies fail because they didn't keep their code clean, and I've seen it over and over and over. If they're not willing to even think about that and hear all of the discussion and planning and design that's happened over the last couple of decades over clean code, then probably things are going to be difficult with them in other ways. And that's, just an unfortunate truth.
Hi. My name is Ben. I'm an entrepreneur. I'm an entrepreneur, and actually at the flip side, I'm aware of technical debt. I'm going to have to hire some freelancers to build me some software. How do I, approach that and say, well, I'd like you to use some tools to show me that your code is good, clean. I mean, I'm sure they don't want to have me assume that they don't code well.
Right.
But how do I evaluate? Because I can't look at the code and know what to build, right?
Right. Ask them what their process is. Right. So a team that has a good process in place that takes code quality into account is going to be delighted to tell you that, because of exactly the issue that Eric raised, which is that so many clients aren't interested in hearing that. So if you are interested, that's going to make a developer who has a good process really excited, because now they know that they've got a client who gets it. I think that's just about all you need to do. You could, if you know what languages they're looking into, you could look at what code analysis tools are available and ask if they use them or are willing to use them. But most likely the ones who have good process will be happy to tell you about it.
Well, again, the answer would be easier. Just tell them what the benefits are. Simple as that. Those customers that don't know about technology, just tell them, hey, if you're using this is the benefits to you. Then they'll get it.
The other answer might be to seek a second opinion. Let the developers that you eventually hire know that after 3 months you're going to have someone come in and look the code over.
Can we use the microphone, please?
I'm sorry.
He's going.
My advice is just to seek a second opinion and let the developers you hire know that that's going to happen. After 3 months, bring in someone seasoned to look it over for a couple of hours. Be aware that generally developers don't like each other's code. So it will probably be a harsh review, but a seasoned professional who knows that they're coming on for 2 hours, there's no chance that they're taking over the project, will probably give you an honest opinion of where you're at.
But that's also a good point. Like, you can't ask for a second opinion, and there is all this worry. Every developer, it's in their best interest to tell you the other developer's code sucks and you need to pay them to rewrite it. Right? Everybody has that in their head when they're doing these negotiations. That's the nice thing about an analysis tool, is they're imperfect, but they're impartial. Right? So they're not going to give one piece of code a 3.5 GPA because they like that developer. They're at least seeing something in the code when they see it.
Hi, I'm Rob. I'm a sales consultant that helps startups generate revenue, initial revenue. This is a very interesting conversation because for those of you who are selling development services, you should consider the fact that in some cases you don't have a technical problem, you have a sales problem, right? So if you're getting hit with something like you were mentioning, where somebody down the street can do it for cheaper, absolutely right? I can do it for cheaper too. But let's have a discussion about that. What's the definition of cheaper, right? These are the kinds of conversations. So when you look at this, I mean, I completely agree with everything you're saying here, because I just left a startup that had this exact problem, who's in chapter 11. My advice is just don't confuse the technical issue with the sales issue, because you can overcome those objections in a sales process versus the technical issue that you're dealing with.
I'd like to add in one more quick analogy, if I might. So this presentation now has everything, including the kitchen sink. Another way to think about technical debt is, if you live with housemates, You might have a very clean kitchen on Sunday afternoon. Monday afternoon rolls around and you're rushing from place to place, and it's a little easier to throw that one plate on a fork and a knife in the sink thinking, oh, you'll clean it up later, right? That saves you a few seconds. Of course, then your housemate comes by later that evening and they're like, oh, there's already something in the sink, so I'll stack my plate on top of that and we'll clean them all up at once because that'll be more efficient. And then, of course, over the course of a couple of days, you get a sink that is completely full of dishes, and now Wednesday night you're making pasta for dinner, and you go to strain the pasta and there's nowhere to put the colander because the sink is full of dishes. So now before you can even make dinner, you have to stop and spend 45 minutes cleaning up the dishes, right? And everybody's familiar with processes like that. It could be a filing system or that sort of thing. And of course, we all know what the right solution is, which is if you spent that extra 30 seconds in an incremental basis, you wouldn't have to spend that 45 minutes on Wednesday. Everything would go faster. And that's what a regular refactoring process gives you in your software. It's just little incremental steps that aren't so expensive that keep you from getting into those big disasters.
So my question is actually answered by a man in an orange shirt about code consultants. And, someone like yourself or your company already coming into a company that's already spent a little bit of human capital and time in developing something, and they realize, oh, this is not coming along quick enough, and we're not meeting our benchmarks, and maybe we need some outside help. So do you guys offer that services? And I understand that you say, every developer is out there trying to get the account for themselves, but at some point it's kind of like, okay, so we're at this point, we need someone else to kind of look over and say, hey, maybe you could have done this better, or maybe you need to go in this direction because that's, the platform is changing in 2 years.
Absolutely, we do that as a business. And by the way, I should introduce to everybody the gentleman in the yellow shirt is Judson Lester. He's the co-owner of my company. That's why he's sitting behind the camera. But yes, we do offer those services, and I think any reputable software consultancy would. When people come to us with an existing project, the first thing we do is start with a small statement of work that's, depending on the size of the project, 5 to 20 hours, where we are going to do nothing but analyze what's there. We're going to read through all the code, we're going to look at the database schema, we're going to run it through some analysis tools, we're going to see if you have a test suite, if it passes, how much of the code is covered by the test suite, to get a picture of the software, not just to tell you what we think of it, but also so that we could make more accurate estimates of what it would take us to make changes going forward. Because that's usually the next question is, all right, well now what's it going to cost to add these 3 features? And until we understand the existing code base, we can't really. So whenever we're looking at a code rescue or a takeover of an existing project of any kind, we start with that kind of analysis. But we're also happy to do that, just on its own. Like if you're deciding between 2 other developers and want to get a third opinion who's not invested in getting the project for themselves, that is something that you can do, is involve a third company, and we'd be happy to do that too.
I had a quick question on technical debt and kind of the trade-off with real cost. So the question is, code isn't so binary as it's either good code or bad code. There's plenty of code in between. So when you get somewhere in the middle and you say, yeah, we could continue refactoring, or we could throw a bigger computer at the problem and say, we have a cost problem with this technical debt. Instead, we could throw more EC2 instances at it or something like that. I guess, I know you have to say that that's bad because it's not clean code, but when do you ever make that determination that it's good enough to just throw more money at a cost problem?
For the primary cost that I'm talking about of technical debt, more computer instances aren't going to help you. So yes, you could have technical debt that is slowing down the execution of your software, and you could try and beat that with scaling. What I'm talking about as the main cost is that it slows your developers down getting their work done. And if what you're worrying about is the difference between $200 and $500 per month on how many EC2 instances you're running, I would say you're probably looking at the wrong problem for your bottom line, because what you should be looking at is what fraction of the time you're taking for your developers, who you may be paying $75,000, $100,000 a year for. So something that takes them an extra week to get their job done because the code is poor costs way more than any server solution that you're looking at. So labor costs always trump everything, and it can be hard to think about the incremental cost of labor when you're paying people salaries, but that incremental cost is in how long it takes them to get their job done. Yeah, if you've got something that's a minor performance problem and you can beat it with scaling, then absolutely go ahead.
Okay, let me answer that also in a different way from a business perspective. We had a great presentation by a man named Gene Kim. He did a book called The Phoenix Project, I believe. Go take a look at it and see what he talks about. He started a company called Tripwire, and they were able to come out with a new product every year. And then things started slowing down, a year and a half, 2 years, and guess what happened to the revenue stream? So you want to be able to do things quickly, and having clean code helps you do things quickly and make your business effective.
My name is Adam. My question is, what sites or software do you recommend in this quarter? Do you have some recommendations?
You mean in terms of analysis tools?
Right.
What language are you writing in?
I don't know.
You don't
I'm
know? So there's different tools for different languages, and the different language communities have different levels of investment in it. All languages have tools for testing code coverage with automated tests. That's one important metric. All languages have what are called linter tools that will look for automated, look for various warnings, misuse of variables, things that are likely mistakes. All of those exist in every languages. There's a tool called SonarQube that will look for things like duplicated code and excessively long and complicated code. And it has plugins for 8 or 9 languages, I think, and it's a free tool. There are nicely integrated commercial tools, at least for Ruby and JavaScript, which are the 2 languages we work with the most. We use one called Code Climate that does both Ruby and JavaScript. There's another one called Sidekick.js that just does JavaScript. But Google around for code quality tools for the languages you're interested in, or shoot me an email or come talk to me afterwards, because yeah. I think
might have a put that there.
Okay. Yeah.
Hi, my name is Bo. My question is really, so we can talk about clean code, but there's so many different technologies out there, different frameworks. How do I choose the right framework? Because we've seen some frameworks come, we've seen frameworks go, and all of a sudden you have multi-million-dollar projects that just went down the tubes because the framework is not being developed.
I want to say that for most projects, the best reason to make a framework decision is to find the right people first. The people who are smart, experienced, invested in getting your job done right, and pick the framework they're most familiar with. That's usually the best call, because most of the frameworks are equivalent for most purposes. Now, that's not always true. For example, if you are going into a project that you know needs massive scalability and high concurrency, then you don't want to start in certain of the other frameworks. And that is a very specific need that you need to pick certain frameworks for. And for that task, I would find somebody who knows most of the technologies reasonably well, and they could advise you on what's the right one for that job. But most of the time, the answer is the one that will make your developers happiest and most productive. Because again, your developers' time, their salary is your biggest bottom line cost.
Hi, I'm Nick, and my question is about the hiring and onboarding process when we're bringing on developers to work on projects that we're managing. So of course we want people that are going to understand this idea of technical debt and have the experience to sidestep the common pitfalls. Are there any questions that we could be asking during interviews and also through onboarding that would help us make a good determination on whether somebody has that experience?
I would start by make sure you've talked to someone beforehand who understands software best practices to compile a list of questions about specific best practices. So I would ask about agile process, test-driven development, Scrum, a few other things like that, to not see that they have specific answers, but see that they understand these issues well enough to talk intelligently about them, right? right? I mean, you might even run across somebody who's like, oh, I hate test-driven development and it's awful, etc. I would personally be very skeptical of hiring that person. But if they have that opinion because they've used it extensively and have a lot of experience, that's still a lot more informative and more interesting than somebody who's like, what's that? I don't know what test-driven development is, or I've never, I've heard of it, but I've never used it. So at least find people who can talk intelligently about the standard sets of software best practices.
Evan, you and I talked before. Isn't that what you do?
Well, we are a software development company. We are very process-focused, which is why I'm up here giving this presentation, but yes.
Thanks for your presentation. Andy Wilson, Chief Rector. I had a question about the movement from waterfall to agile and whether there's implications around technical debt. So when I first started developing software, it was very strategic, it was very life cycle driven. Right now we're kind of constantly reworking the software. Is there any causality there, or maybe not?
There's a bit of a dependency. Remaining agile requires more attention to technical debt because you have to be able to change the direction of your software on a weekly basis, right? And that's, that sounds bad, but that's the reality of what the web world is like, right? New features need to come out constantly, and we don't know this week what we're going to be building next week. So a greater attention to technical debt is necessary to make agile possible. But it also, agile processes give you more opportunities for controlling technical debt, right? Because you can be doing weekly code review as opposed to giving somebody a set of features and saying, here, I'll see you in 3 months, right? Where they can get into the weeds if it's a solo developer who isn't paying attention to the quality of their code.
Hi, I'm Ben Mahmoud, and I've managed software development for many years. I agree with everything you've said. From my experience, the single biggest issue with technical debt is bad database design. I would argue that most even mid-level developers aren't capable of designing a solid, stable database. And so that's where I would always start to reduce debt. Once the database is set, then it becomes much easier.
I definitely agree that database design and schema design are a huge issue. But of the 2 major code rescue projects that we have going on right now, one of them is its technical debt is dominated by a poor database design. And the other one actually has a pretty clean database design. When we looked at re-implementing their project from scratch, we actually were going to reuse their database with only one change. But their code is so bad that the quality of the software is the worst we've seen, even though the database design is good. So I think both places can contribute to technical debt, and it depends on a case-by-case basis. I suspect you've been unlucky and had just a lot of experiences with that database design, and you have my sympathies.
On new projects, before they get in debt, the question I originally asked was looking into the future. For instance, if you hire, the only people available are Flash designers, all right? Well, given mobile technologies, it's no longer supported. So the question I have is this: looking into the future, you've got Ruby on Rails, you've got Ruby, whatever, you've got a variety of different frameworks and languages, and you can go back to assembly and machine language. Okay. The question I have is for this: for people before they get into debt, what is the process that they choose a particular community, whether it be PHP or Ruby or whatever? Because PHP community says Ruby on Rails is unscalable, and then of course Ruby says, so you get this crosstalk back and forth. Ruby on Rails is good for quick deployment, yada yada yada. Are the libraries going to be supported? Things of that nature for the future. That's the question.
I'm not sure what the specific question was.
The question is before you start your project, what is going to be looking into the future, what is the least debt you'll get into, given, like if I went into Flash, of course I'm going to get debt almost from the start.
Right. Honestly, the least debt you're going to get into is starting with people who have good process, because that matters a lot more than one language.
They might be Flash programmers.
If Flash programmers are all you have, I frankly hope they're willing to learn some other languages, because as you said, Flash isn't supported on mobile anymore, and it's kind of dying out on the desktop.
So I'm saying, in other words, looking at the libraries going to be supported in the future. That's the question.
Specifically, which ones do I see supported with? Okay. Well, I'm not a huge fan of PHP, but I have to recognize that it's got 5 times as many developers as anything else because it was the first big language for the web. So PHP is not going away anytime soon. Java is not going away anytime soon. Neither of them are anything close to cutting edge anymore. And most of the best development of process does not happen in those communities because the people who are really interested in driving software process going forward have gone to newer frameworks. I think Ruby on Rails is an excellent framework. It's getting a little long in the tooth, but it's certainly not going away anytime soon because it's been so popular in the startup space, particularly. I think it will be with us for at least another 5 to 10 years and will be supported out 15 or 20. What's happening next? The big movements are in JavaScript-heavy frameworks, some of which I'm personally skeptical about. But certainly a lot of heavy JavaScript on the front end is going forward. I think you would be safe with any of the big names in that field in terms of having support. So the big names in JavaScript front ends these days are Angular, which is our preference, but Ember, Backbone, maybe Meteor, etc., maybe YUI. Some of these are pretty well adopted and are likely to be supported at least at some level now for a good long time. On the back end, the 3 bigger developments that we are keeping our eyes on are Rust, Go, and Erlang, where Erlang is the direction we lean for things that need that kind of. So for everybody who wants to know, those 3 languages, Rust, Go, and Erlang, are generally designed for higher scalability and higher concurrency applications than you can do with most of the traditional frameworks from the last 10 years. We personally lean Erlang in that direction. It's been around since '87. It has doesn't have as tight-knit a community as many, but it has a pretty good penetration and adoption. Rust and Go are both very new, but they're backed by big players, right? Go is backed by Google, that's where the name comes from. Rust is backed by Mozilla, so both of those have a good shot at it. At the moment, they're so new that I wouldn't throw all my eggs in that basket, but I would keep an eye on them because I think they're good going forward.
Hey, we got time for one more question.
Yeah, my name is Alice Law. I have an IoT company. Yeah, my name is Alice Law. I have an IoT company. Just as you say, we have a new tool coming up every day. So, you know, just like the other gentleman talked about the database. So before everybody used SQL, but now people don't know SQL anymore. Right? So how can we handle it with all those change? You know, sometimes it's just overwhelming.
Right. Oh, it can be overwhelming. I mean, for me, that's the biggest frustration and the biggest joy of working in this industry is I have to relearn all of my tools every 6 months if I want to stay anywhere near the cutting edge. I mean, this is kind of why you see tools like PHP and Java sticking around for so long. It's because once you've invested 5 years in learning a tool, you don't really want to start over. There's a huge amount of fear with starting over. On the other hand, newer tools are usually developed for real reasons. They give us real advantages, right? I mean, C has been a fantastic programming language since, what, the 60s? When was it? Something. But it's really not very well suited to modern computing environments or certainly to the web, right? Very few people use it as their primary web development language, and I wouldn't recommend it, even though there are billions, literally billions of people who know how to program in C out there. So, yeah, I would say good developers should be willing to learn new tools and ideally excited about it. And you need to be willing to evaluate tools based on what benefits they bring you. And switching is usually not as scary and as complicated as you expect it to be. Change is more frightening in advance when we're anticipating it than it usually turns out to be when it comes around.